puts it on layer 0, but we don't want to freeze layer 0, so I created the corridor layer. So what you'll notice is when you go around the curve where the elbow is, and when you go to the cul-de-sac, right, your standard 20 meter right-of-way goes through, your standard 20 meter right-of-way goes around, and it's not representative, right? The edge of the gutter line, this point here, right, this is the edge of asphalt, that's the gutter, that's the top of the curve on the front, that's the top of the curve at the back. This is the gutter line. It's supposed to be way over here, and it's not. Same thing over here, right? The gutter line, remember these 3 lines, there's the edge of asphalt, there's the gutter, top, front, top, back at curve. It goes through as if it's 20 meters wide. It's supposed to, that's the gutter there, along with this, right? So it doesn't represent the cul-de-sac and the elbow, okay? It also doesn't represent the intersection, okay? But I'm gonna ignore that for now, and I'll talk about it later. Okay, sorry, let's go back to this. So what we need to do is accurately represent the widened areas, okay? And there's a technique, a very common technique that's used to do this. And what we have to do is, you remember how you build a corridor with 3 parts, right? There's a horizontal alignment, a vertical alignment, and a cross section. Well, we need to do the same thing for these widenings. I need a horizontal alignment of the gutter, I need a vertical alignment of the gutter, and I need a cross section for the gutter. And I'm gonna add those pieces to this corridor, okay? And that's how we build this. So I'm going to demonstrate how to do that on the crescent. The way you do it on the cul-de-sac is actually in a PDF. So I posted, I believe, should be available. Let me see here. If we go back to content, if we go to course documents, you will see module 3. So I'll make that available now. Edit. And there is a zip file here. So let me just make sure get access to this. So here's some stuff you need for module 3. So if you download module 3, you will see a PDF. So put it on your desktop under the course code, under downloads, create a new folder, call it module 3, module 3, whoops, module 3, and put it here. Unzip everything. So I'm going to go desktop, CPA, downloads, module 3. I'm going to unzip all this, extract all. And what you have is one PDF. So if you go to all the downloads, you'll see PDFs 0 through 6, module 1. And then 7, 8, module 2, and then module 3, number 9. And what PDF 9 walks you through is how to create the cul-de-sac widening. Okay, and it shows you exactly how to create the cul-de-sac widening. Okay, I'm going to show you the elbow. That way you have a live demonstration of the elbow, and then you have a PDF that is it's the same process, just different geometry for the cul-de-sac. Okay, so there's a video. There will be a video of today's class, so you can see how to do the elbow, and there's a PDF with step-by-step instructions, so you can do the cul-de-sac. Okay, the cul-de-sac. The way the cul-de-sac is shown in the PDF is a slightly different technique. I'll talk about it later after I demonstrate the elbow. Okay, so I want to show you 2 different techniques. One is going to be a live demonstration, and one is a PDF step-by-step instruction. So you can use this as a guide, but you can employ the technique I'm going to use. Okay, there's a couple of options here. Okay, so let me do one, and then the other one will make sense once we get to it. So back to here. Okay. Civil 3D is lagging a lot. When is it? Okay. Trying to slow down as best as possible. Okay, so what I want to do is widen the elbow. And remember that the inside is okay. The edge of asphalt is exactly where it's supposed to be, because it doesn't widen on the inside, just on the outside. Okay, and I don't think I'm sharing my video. That usually slows things down. I don't think I am. No, okay, you can't see me, but you can hear me. Okay, I'll try and do this slow so that the lag time matches the voice I'm going to do. The first thing we need to do is take away the stuff that's wrong. Okay, so the outside turn here is incorrect, right? The last time it's true is right here, right? That's where the widening starts. And then it becomes true again here where the widening ends. So between these two stations, the outside of the turn, in my case on the left side of the road, is wrong. So I want to remove that error. To do that, what I need to do is chop up the corridor. Okay, right now there's one entire region, it's called, of the corridor, and I need to split this up. So here's what I'm going to do. I'm going to click on the corridor, I'm going to right click, and I'm going to go to corridor properties. So when you go into here, you'll see this directory tree. So not information, but the parameters tab, you'll see a directory structure where the horizontal alignment is here, the vertical alignment is here, and if you expand that tree, you'll see the cross section. So there's the horizontal alignment, there's the vertical alignment, and there's the cross section I'm using. Those are the three pieces that are married together to create this 3D shape of the road. This piece here, right, not this, but when I expand it, this piece here is called the region, right? And when I select it, it actually highlights what's happening here. So when I click here, you see the center line of the road is highlighted. But when I click here, you'll see the region, the entire edge of the right-of-way, all the way around, is highlighted. It's one piece, it's one region. I want to split it up into multiple regions. So in this case, I'm going to chop it up to begin with in 3 parts. I want the first part to remain, then I want another piece that goes around the curve, and then I want the rest to remain. So this one region needs to be split into 3. Okay? So that's the first step, just so I can isolate the piece that I want to modify. So when you click on here, right, you click on this, again, not on the alignment, but expand on the region, so you can see the highlight in blue. Right click, and there's a command called split region. When you start that command, it takes a little bit of time to start up, so give it a minute. What you want to do is snap to, you don't have to type anything, snap to either the node or the end point or that exact spot where the typical 20-meter right-of-way ends and the widening begins. So I'm going to type in node because I have a point there, so I'm going to snap exactly to here. I want to chop it here, and I want to go around to here, node. I want to chop it here as well. Okay? So make sure you snap exactly to the spot. And now I'm going to hit enter. Okay, there's more chopping to do later, but right now I'm just going to work on this piece. So when I'm done, now you'll see 3 pieces, okay? And you'll see the warnings. Before you make any changes, just say okay and let it rebuild. You have to select the chopping points and then let it go through the full cycle of actually splitting the region before you make modifications to it. It's just a bit of a, I don't want to call it a glitch, but one of the little fussy points about Autodesk Civil 3D, right? AutoCAD's a little bit fussy that way. So when you pick the chopping points, just let that whole process begin and end before you go back in and change things. Okay? If you start changing things before you let it rebuild, it gets a little bit fussy. Okay. So now when I click on it, when I click on the corridor, you'll see some extra grips here at those 2 selected points. And if you right click and go back to corridor properties, you'll see 3 regions instead of 1. And if you pick each one, you'll see it highlighted. So the first one you can see is that first part. Then there's the piece that I'm going to modify, and then there's the piece at the end, which will be modified as well. You have to do something at the end, okay? But I'm not going to show that right now. I'm just working on this piece here. So this piece is where I'm going to do some of the work. I have to change some stuff here. Okay? So now I've isolated. I've chopped it up into 3 parts, and this middle piece is the one I'm going to change. Right? Everything before this is okay. Everything after this, right up until the cul-de-sac, is still okay. And that's why you're going to have to modify the end as well. You're going to have to chop this one up as well later. Okay, but we'll talk more about that. Let me demonstrate the elbow from beginning to end, and then the discussion about the cul-de-sac will make more sense. Okay, so there we go. So if we imagine going around this curve, right? Remember, the inside is typical. It looks like a standard 20-meter right-of-way. So half the road from the center to the right side, in my case, the right side of the road is correct. The left side is incorrect. So what I'd like to do, I'm going to go to my cross-section. I'm going to make a copy of this point here, just the assembly point. When you make a copy of the assembly point, I'm just going to put it down here, a little bit lower. When you make a copy of the assembly point, it also copies the sub-assembly parts. So if I was driving along my road in the direction of increasing change, 0 is here, 20, 40, right? If I look in that direction, my right hand is the right side of the road. So the cross-section going around the curve on the inside is correct, just like it normally is. So what I want to do is I'm going to change the name just so I can find it. It actually indexes it when you make a copy, so it's going to be called right-of-way 1, I believe, or right-of-way 2. I don't want right-of-way 2. I'm going to say 20-meter right-of-way, and I'm just going to say R for the right side only. And then I'm going to modify it. This is not representative. This side is not representative. But on the inside, this is correct. Right? So you go along your standard 20, and when you go around the curve, the inside is exactly the same as before. The outside is wrong, so I deleted it. So now what I want to do is I'm going to go to the corridor and replace this cross-section with this cross-section. So this is the first step. Okay, so I'm going to go to this corridor, right-click, go to Properties, and then I'm going to go to that piece in the middle, right, that region in the middle, and I'm going to swap out the right-of-way. Not the full 20, but the 20 right side only. And when I say OK, watch what happens. Okay, it's going to want to rebuild, so I'll say OK. Rebuild, and half the road disappears. So now, what was wrong is gone. So now I don't have the wrong thing on the left side, I have nothing on the left side. So that's the first step. So get rid of what's there because it doesn't represent. So now I have this gap, right? So I'm going to look at it in 3D, Object Viewer. Right, so now I've got that piece missing on the outside. Okay, so that's the first step, right? So the inside is okay, but the outside is wrong. Okay, now I need to create what's representative on the outside and then finally add it to the model. Okay, let me just get rid of the water main. Okay. The next step is to create. You need three things. You need the horizontal alignment, you need the vertical alignment, and you need the cross-section information, just like a corridor, okay? But I'm not going to create a new corridor, I'm going to add it to the existing corridor. I want one complete model. But you still need the constituent parts, plan, profile, cross-section. So I'm going to freeze this for a moment. I'm going to freeze this because it's in the way. I want to create an alignment of the gutter. Okay, so here's the alignment, right? These three curves represent the widening on the outside. What I'm going to do is I'm going to create an alignment that includes that, plus I'm going to start a little bit before that and go a little bit past that. So what I'd like to do is I'm just going to trace it with a polyline. So I'm going to draw a polyline. I'm not going to snap to this intersection. I'm going to snap to a near point just before. So I want to start my alignment before the widening. Then I'm going to snap exactly here, this end point. And then I'm going to use an A for arc, and I'm going to snap to this end point, and I'm going to snap to this end point, and I'm going to snap to this end point. So now I've traced the widening, and then I'm going to go L for line, and I'm going to snap to a near point on the straight line. So now I have the alignment of the widening, but I have a little bit of alignment at the beginning and a little bit of alignment at the end. I don't want to start my horizontal alignment to be exactly at the beginning and exactly at the end of the widening. I want an alignment that starts before the beginning and ends after the widening ends. Okay, so I want my horizontal alignment limits to be greater than the actual work that I'm going to do. Okay, and this is a good habit because what happens is sometimes when you're working on the edge of something, it may or may not get included. This way, everything I'm doing is inside the horizontal range, so it'll always be included, right? But if you design right to the edge of something, it gets a little bit finicky. So, I'm right on the edge. Is it equal to and less than, or is it just less than? And if it's less than, if you're right on the edge, it may or may not get included. So this is one way of ensuring that all the work you do is inside a space that is, whose horizontal alignment is beyond the work you're going to do. Okay, so this is always just good practice. So this is just a tip or a trick that I always use. Sometimes it works where the alignment can start and end exactly where the widening start and end point is, and sometimes it doesn't. So it just depends on some of the settings in AutoCAD. And sometimes there's settings that you're not even aware of, so you have to be careful. I find it's good practice to make sure the alignment range includes the actual widening range. It's not at the limits, but beyond at the beginning and at the end. Okay, so this is just good practice. So now that I have a polyline of the horizontal alignment, right, I'm going to create an actual horizontal alignment, right? So what's the name of my road? My road is Street X, right? That's the name of my street. I'm now going to create an alignment for this. So same procedure as before. Alignment, create alignment by polyline. I'm going to pick near the beginning. I want the station values to increase parallel and in the same direction as center line. So if 0's down here, I want 0 to be at this end, not at this end. So I'm going to choose this front half, the beginning half. When I hit enter, yep, I want that direction. You can see the arrow indicating the direction of increasing chainage, right? So the direction of chainage for the edge of the road is in the same direction as the center of the road, okay? And then I have to give it a name. So what name am I going to give it? You can call it whatever you want. Bob, Mary, Abdul, whatever. You can give it any name, but if you give it a meaningful name, it'll actually help you find it on the list. So I'm going to repeat the center line name of the street, and then I'm going to give it its description. This is a crescent, right? It's a crescent. It's a crescent on the left side of the main road. It's on the left side, and it's the first one. Okay? If there was another crescent later on, I would call it crescent L2. And if there was another crescent, I would call it crescent L3. And if there was another one, I would call it L4. If there was one on the right side, I would call the first one R1, the second one R2, the third one R3, and so on. Again, you can use any name you want, but if you give it a name that kind of describes where and what it is, it's helpful later when you have to kind of select it on the list or so on. Okay, so this is part of Street X, so that's the first thing, the name of the road. It's a crescent, not a cul-de-sac, and it's on the left side of the road, the left side of the main road, and it's the first one. Okay. Next thing you want to do, just like the horizontal alignment, is give it a name and turn this off. Okay. Say okay. And there's your horizontal alignment. You'll notice 0 is at this end, right? And positive chainage increases in this direction, 0, 20, 40, and so on, right? Now, you don't need the labels, okay? But they're there for reference. This, nobody needs to see. This is something you're doing to enhance your model, but it's not part of the drawing that you're going to present on paper. It's just something you need to create so that you can create the design model that you're going to need for grading and servicing later. Okay. Any questions about the horizontal alignment and some of the details related to that? Again, if you want, you can unmute yourself and ask a question. Any questions about that? Next thing I want to do is create the existing ground profile of that gutter. So I'm going to go over here, right? I know it's on center, it's near the cul-de-sac. If I go here, remember my cul-de-sac zone starts here and ends here. What layer should the new alignment be on? That I would leave as the default. The actual alignment is on layer 0. However, the pieces, if you go to the style for the alignment, you'll see that the actual parts have their own layers. Okay? So you could just leave it where it is. Alignments, I don't mind leaving them on layer 0 because the parts are not on layer 0. Okay? So I would just leave that. If you want to put it on a different layer to freeze it, you can. But again, nobody needs to see that. That won't be presented in your drawing. Okay? So how do we create the profile? Well, I'm going to treat 0 at this end, right? I've got 0 here. Positive chainage is increasing from left to right. So I'm going to lay out this profile on the top, up here instead of down here. So anything I draw for a widening on the left side is going to be above. Anything I draw on the right side is going to be below. So it depends what your road's doing, right? Mine is turning to the right, so the left side of the road is my widening. If yours is turning to the left, the right side of the road is widening. Okay, so the definition of left and right depends on the direction of increasing change. So I'm just going to put mine up here. I know it's related to this, okay? So I'm going to say profile, create a profile from a surface. Now I'm going to go find that alignment, right? The crescent. And I want to see the existing ground. And I can change the style of the existing ground right here. Road EX, that'll give it that red dashed look, like the main road. And then if I draw it in the profile view, I want to change the style left to right. Just use the road one, which is left to right, just like the other style. Create the profile view, and then I'm going to click above. So there's the existing ground profile of the gutter. You don't need the labels. This white stuff you don't need, right? So that's the existing ground along this alignment. Okay, and notice the length of the gutter is longer than the length of the center line. Right? The length the distance between these 2 points, right, the distance between these 2 points on the center line is shorter than the distance it takes to go all the way around the outside. And that's one of the things that we looked at when we decided what should this slope be so that the gutter line meets the minimum requirements. Okay? Any questions about that? Existing ground profile for the gutter. Okay. Here's where it gets kind of tricky. You have to understand a few items. The profile, the design profile for the gutter, starts, I'm going to put a point right here, starts here and ends exactly here. Right? So that's the first PVI station and that's the last PVI station. So I know the stations for where the widening starts and where the widening ends along the gutter. Right? So I'd like to project those 2 points. So I'm going to say project points to profile view. There's the station, enter, and I'm going to bring it in here. And I'm just going to select existing ground so that it's in range. I don't want it to go to 0. So I'm going to say okay. So that's the station of the beginning of the profile and that's the station of the end of the profile. I need to determine what the elevations are. Okay, and here's the trick. When you create a corridor, let me bring the corridor back. This corridor. When you create a corridor, you can actually create a surface from the corridor. So if I go into the corridor, right-click, properties. Right, as I add data to build this corridor, I can actually create a surface. Here's how you create a corridor surface. So you click on Surfaces tab, and you do 2 things. You click this first button, that creates the corridor surface. There's nothing in it right now. If you want to change the name, you can. I don't like the indexing, so I just make the surface name the same as the corridor name. And then what are you going to build? You have to give it data. Remember when you created the existing ground? You created the surface, and then you had to say use the point group, use the break lines, use the boundary. Okay, so right now I've created a surface, but there's no data. So once you create the surface using this button here, you then go to the plus sign here, and you're going to use the top. The top is trivial, right? It's the corridor subassembly parts. So I'm going to hit this plus sign, and there's the surface. So now it has information to build the surface. If you want to turn this on, you can. Add those lines as break lines, and then it'll triangulate accordingly. Okay? So then you say OK, and you rebuild, and it builds the surface. Okay? Now, if you don't see the surface, it's because maybe the style isn't there. So now you have 2 surfaces. And notice the icon has this little road in the corner. So I'm going to right-click, surface properties, and I'm going to change this to standard so I can see something. So there's the corridor surface. Okay. You can see in here, it looks correct. Here, all these long triangles are a problem, right? That's where a boundary would fix that. I'm not going to worry about that just yet. And you can see here, it kind of triangulates. There's still a gap here, but then it creates some triangles that aren't meaningful. Even though there's a surface there, they don't make any sense. Let's look at this in 3D, Object Viewer. Okay, there's the surface. And again, you might have a spike at the beginning or at the end, so you got to be careful. Okay. And in my case, my corridor model went all the way to the end. I need to bring it back to this point here, and that gets rid of the spike. Remember that? The range of the horizontal alignment is greater than the range of the vertical alignment. So you ask the corridor to build from the beginning to the end of the vertical, not the horizontal alignment range. Okay? So here we go. So the spikes are gone. So if you look at the road, it might be hard to see. You can actually see the cross section, right? Right at the end especially. Right? You can see, let me zoom in here. You can see here's the center line. Here's the 2% down. If you zoom in here, you can see the gutter. You can see the face of curb. You can see the top flat part, and then you see 2% up to the boulevard. Okay? So it builds a surface. Now the thing you have to understand now is in that zone right here, right, where the typical standard 20-meter right-of-way ends, this elevation in the gutter is correct. And the elevation at the other end, this elevation at the end of this gutter alignment is correct. So that's what the elevation is right now. And that's what the elevation is right now on this surface, right? It's correct. Everything in between is garbage, but the station, which we already established, is correct. The elevation of this surface at those two locations is actually the elevation I want for my profile of the gutter. So now I'm going to do something a little different. Okay, so I'm going to delete these points. Remember I projected these points to the existing ground surface? I'm going to do it again, but I'm going to do something a little bit different. So I'm going to go to Profile, Projection from the project to the profile view. I want this position and I want this position, right? Because those are the stations. But the profile design elevation comes from this surface, the road surface. So let's go back to here. Pick the grid. And now instead of getting, I don't want to use 0. Instead of getting the elevations from existing, I'm going to get it from the proposed road, right? Because at each end, those elevations are correct. So I'm going to click on there, and I'm going to say OK. And now you see the 2 points. The position, the station of these 2 points is where the widening begins and ends. And the elevation of those 2 points is the elevation of the widening at the beginning and at the end. So what I need to do now is connect the dots between these 2 points with a design profile, which represents the gutter profile, because the elevation at the beginning all the way to the end is one constant slope. Does anybody remember what the minimum slope is for a gutter? Remember when we designed our center line? Exactly. So this gutter, right, I'm going to create, remember this green thing? I want to create a layout profile right here by connecting those 2 dots. So here's what I'm going to do. I'm going to, I don't like to type, so I'm going to list the alignment name. So there's the name of the alignment, right, the center line alignment of the gutter. And I'm going to create a profile, a design profile. So I'm going to go to Profile, Create by Layout, pick the grid. I'm going to give it a name. I usually repeat the alignment name. That's why I cut and paste the name. And I call this Finish Ground, the profile design. Okay, and you can accept all the defaults. Say OK. I'm going to set my OSNAPs to node. And then I'm going to use this dot here, right? This, insert PVI, and I'm going to connect the dots. I'm going to click here, and I'm going to click here. That's my design. When I hit enter, it's going to annotate that. What do you think the slope of that line is going to be? Any guesses? Can you describe what the slope might be? What do you think the gutter slope's going to be? It's going to be greater than 1%. A little more. Yes, exactly. Awesome. Everybody's thinking. It's going to be a little more than 1%. Why? Because when I designed this to be 1.5%, I rounded it up, which means the gutter will be at least 1%. So this should be, by no surprise, at least 1%, a little bit steeper than 1%. And when you see that, hopefully we see that, when you see that, you shouldn't be surprised. It should be what you expect. Okay, so let me hit enter. And there's the slope, a little bit steeper than 1%. Okay, I hope that you're not, saying, wow, that's amazing. It's not amazing. It's what you expect. The reason we designed this to be at 1.5% is because we knew it would guarantee this would be at least 1%, a little bit steeper than 1%. So this isn't really a surprise. It's actually a verification that we did the centerline design correctly. Okay? Is anybody surprised by that? Okay? You might be impressed by it, but you shouldn't be surprised by it. Okay? It's exactly what I'm expecting. As a matter of fact, I'm not designing this. I'm just creating the data that represents it. I've already designed this when I input this value here. Okay, so this information here is not really designed. It's just part of the model data that you need to create the corridor. Okay, so I'm not designing. I already designed the gutter a long time ago. I'm just creating the data that represents that design now. Okay, so now we have a plan of the widening, the horizontal alignment. I have a profile of the gutter, the vertical alignment. I need a cross section. So now I need to create another assembly with sub-assembly parts. Keep in mind now, when I create this sub-assembly, what the geometry for horizontal and vertical alignment represents. So for instance, I want to create a new assembly. So how do we do that? Well, we go back to corridors and we create an assembly. And I'm just going to give it a name. This is going to be for the elbow. So the cul-de-sac. So I'm going to call it crescent. and it's on the left side of the road. I'm just going to call it crescent L. Okay? Say okay, pick a spot. I'm going to put it right near the profile, right? Either at the beginning or at the end, doesn't matter. I like to put it at the beginning. And there it is. Okay? Now I want to build the sub-assembly parts, right? I want to add all these pieces. Right? Remember, this is the assembly, and these parts connected to it are the sub-assembly parts. You have to remember now, this thing here, right, is being dragged not along the center of the road, but it's being dragged along the gutter line. So this point now represents the gutter because my horizontal alignment represents the gutter. So now what I want to look at, and I'll do a quick sketch here. In the first place, right, the first time I created that, I knew that was the crown of the road. So I went down 2%, down to the gutter, up to the face, across the back, and over to the street line. So this point here represented the center line of the road, the crown of the road. Now I've got another assembly, right? I've got another assembly, but that doesn't represent the crown of the road. It represents the gutter. It represents this position. So now I want to go around. You remember I'm going around the gutter this way, where the center line is here. So I want to, if I'm going this way, I want this point to represent the gutter, where the boulevard is on this side. Remember, positive change is increasing in this direction. The boulevard is on this side, and the pavement is on this side. So with respect to this, I want to go down to the gutter, up the face, across to the back, and over to the street line. And on this side, I want to go to the center line of the road. So I've got 1, 2, 3, 4, 5 pieces, just like I have here. But the reference point is not the crown of the road, it's the gutter point. And it's the left side, right? I want the boulevard on this side, not this side. Remember, positive change in this direction, I have to build these pieces. So now I have to remember how wide each piece is and what the slopes are. Relative to center, this is going to be, if you remember this piece, 3.95, but now I'm going up. It's not going to be negative 2%, but I'm coming out of the gutter, it's positive 2%. And it's on the right side of the assembly point. Everything else is on the left side. Okay, so if you remember these widths, the width of the gutter, 0.3. The width of the face of curb, 0.05. That's this dimension. The width of the top curb is 0.15, and the width from the back of curb to the street line was 5.55. And then the corresponding slopes. This one was 8.33%. This one was 300%, and this one was 0%, and this one was 2%. Okay? And away from center, this one's negative, this one's positive, this one's 0 is 0, and this one is also positive. Yeah, so you remember these numbers. So it's the same geometry, but I'm building it a little bit differently because my reference point is not the center of the road, but the gutter point, with the boulevard on the left side. Okay? If the alignment was going the other way, if 0 was over here and positive change was going this way, I'd have to create the mirror of this. I'd have to use that assembly point and go up, down, up, across, and backward. I'd have to have the boulevard on the right side. Okay? But that's not what's happening. So you have to make sure that when you're building the parts, you remember how you created them. I know positive change is in this direction, which means the boulevard needs to be on the left side of the road. If you draw this, then it'll be backwards. It won't make sense. So you have to be consistent with your model and remember what's going on all the time. Okay? So I'm going to go back to AutoCAD, Civil 3D, and I'm going to go to the sub-assembly point, and I hope this works today. Find out. So I'm going to go back to corridor, tool palettes. I always use that generic one. Remember generic? Generic one. And I only ever use link width slope. And I want to create, again, I'm just going to create them on the left side. I need, on the left side, I need 1, 2, 3, 4. So I'm just going to create them. 1, 2, 3, 4. And then on the right side, I need 1. On the right side, I need 1. Okay, and now I'm going to go change it. Let's create this one. This one is going to be the pavement. So if I change the dimensions of that, it needs to be 3.95 wide, and it needs to go up at positive 2, so that's correct. Now let's do the left side. This is the gutter. I know the gutter is only 0.3 wide. Right? It's only 0.3 wide, and the slope is negative 8.3333. The next piece is the face of curb. So this is only 0.05 wide, and it has a 300% slope. So there's the face of curb. The next piece only needs to be 0.15, and it's flat, 0%. And the last piece needs to be 5.55, 5.55, and it needs to be positive 2%, so it's ready to go. So if you compare this, let me just move it. You don't need to do this, but let me just move it. I'm going to put it over here. If you compare it to this side of the road, right, this geometry is exactly the same as this. But in this one, the reference point is the crown, because the alignment represents the crown of the road. In this one, the alignment represents the gutter. Anybody notice any problems with this? Anybody notice a mistake here? This is not the gutter the way I drew it. It's the edge of asphalt. So my assembly is wrong. If I use this, it's going to be wrong. My reference point should be here. So what am I going to do? I'm going to delete this one. And it usually collapses. So this is wrong. Should be there. This piece is the gutter, 0.3, and it should have a positive slope of 8.3333. And now I'm missing the pavement on this side, so I'll add another piece. Profile, create by, assembly, tool palette. And I'm going to create a link with slope on the right side. And this is the piece that has to be 3.95 with a positive 2% slope. Positive 2% slope. See, the reference point is now the gutter, not the edge of asphalt. Okay. I didn't mean to do that, but it's a good lesson to learn, right? It needs to be this position here. Same geometry, different reference point. Okay, and I'm going to put it here because it represents this alignment. Okay. Before the reference point was here, now it's in the gutter. Okay, so I actually drew this wrong. When I drew this, the reference point should not be here, it should be here. Right, this was incorrect. This is the reference point, the gutter point. Right, same thing here, the gutter point. So I actually drew it wrong on here. I was thinking ahead. In the PDF, it actually uses the edge of asphalt, but I'll talk more about that later. Let me finish this design. Does everybody understand the difference? Why it was wrong in the first place? Okay, that reference point needs to be in the gutter. So now I need to add those parts. So now I have the three basic building blocks for a corridor. I have the horizontal alignment, I have the vertical alignment, and I have the cross section. So now I can add those parts to the model. So here's how you do that. Okay, let me get rid of the surface. So surface properties, I'm going to get no display. And now I'm going to click on my alignment, and, my corridor, and go to the properties. So now I want to add another center line. So to do that, right, I already have the main center line. To add another center line, I go to my parameters. Right, so here's my center line. See that highlighted piece? Right, this is the center line of the road. I want to add another alignment. To do that, we do what's called adding a baseline. All the center line horizontal alignments are baselines. So I'm going to, and that's what the BL stands for right here, BL. So I'm going to add a baseline. Which one? Well, I can choose it from the list. Right, the crescent on the left, or I can use this little green button to actually select it from the drawing. So I'm going to pick it, and then it finds it for you on the list. Okay, but the name, there's only two right now. There'll be at least one more when you do the crescent. The cul-de-sac. So that's the horizontal alignment. Say okay. Once the horizontal alignment is there, you go into here, you put in your vertical alignment. And there's usually two, right? There's the surface, existing ground, and then there's the proposed one, right? This is red dashed. This is a green one. So that's the one we want with the design profile. Say okay. So now I have a baseline, and notice you'll see the highlights here, right? I'm going to collapse this. So there's the main road center line, and the model also includes the horizontal alignment of the gut. Okay. Now notice you can expand to see the regions of the main baseline. There's no plus sign over here for the region of this. So to add the cross-section data, I have to right-click and add a region. And then in which region? Well, I'm going to use the crescent with the left side boulevard. Right? There's three now, remember? Full right of way only on the right side, which is what's happening here. But I want the crescent now, where the reference point is the gutter point. So I'm going to say okay. And now I have that region, right? So center line of road, profile of the road, and then three different regions with different section data. Now I have the elbow, or the crescent. I have the profile for the elbow, and I have the cross section I want to drag all the way around the elbow. So once I add that baseline with the horizontal and vertical alignment, I'm going to say okay. I'm just going to let it build. You don't have to do this, but I just want you to see the progression of the data. Rebuild, and create that. Now it doesn't look very good, right? And it's a function of the frequency. So if I want it to look like a curve, I'm going to go back, order properties, and I'm going to change the frequency. When you add baselines, by default, it always makes them 25. So now you want to go in and change these again. 3 meters on all the tangents, and 1 meter for each of the curve types. 1 meter, 1 meter. Okay. The first one is horizontal circular curves. Spirals, it's trivial, we don't have any, and vertical curves, we don't have any either. But I just get into the habit of always changing them in case I do decide to use them later. Okay. So say okay. It updates. Watch what happens to the model when I hit OK. See how it looks kind of stick figure? It's going to look more curved when I'm done. Rebuild. Now it looks more like a curve. So now the gutter, the top front face, the back of curb, and the asphalt location is in the right spot. And that's how you do the widening. If you look at this in 3D, object viewer, if you look at this in 3D, you can see the bulge now on the outside turn of the crescent. What you'll see now too are a couple of spikes. Everybody see those? And those spikes are there for the same reason that they originally showed up at the beginning, at the end of the main road. Remember, our horizontal alignment starts before the widening and ends after the widening. However, the profile starts inside, right? The range of the vertical design is inside the range of the horizontal design. So now what we have to do is, remember how we grip edit? I'll do this again. Right? Remember this? Used to go all the way to the end of the horizontal alignment, and it caused a spike at the beginning. I'll show it to you again. Object viewer. Remember? Now there's a spike at the beginning. Why? Because the profile doesn't go all the way to the beginning of the horizontal alignment. It starts inside. So what we did to fix that was we clicked on the profile and we made this coincide with the edge of asphalt where the profile starts. Right? And now that, a little bit more, should be exactly where the edge of asphalt starts, which I believe is this piece here, sorry, INT, where the asphalt meets the center line. So now there's no spike at the beginning. Right? So that's gone. Same problem is happening here. So what you'll see is grip. So if you zoom in on the horizontal alignment of the gutter, right, if you click on the corridor, you'll see a grip here, the horizontal alignment of the gutter. So you want to click on there and snap to the node. That's where the profile starts. And at the end, same thing, click on the corridor, grab this grip that's at the horizontal alignment end, and make it coincide with the vertical alignment end. And now it stops and starts at the right spot. So if you look at this in 3D, those spikes are now gone. Okay? So the spikes that you're going to see at the cul-de-sac or the crescent beginning and end alignment is the same issue you have on the main alignment, and that's how you fix it. Just grip edit the range build to coincide with the profile range, not the horizontal range. Any questions so far? There's one more thing to do, and we'll get to that. The next thing you'll notice is this gap in the middle. Right? So it looks like an upside down smile, a frown here, object here. There's a gap here. See this gap? It took that 395 and maintained the 395. Remember, the center line of the road is actually here. So these elevations here may not be representative. I want to design from my edge of asphalt all the way to my actual road center line. Right? So this gap, this hole here, doesn't make any sense. The elevations along this white line here are wrong. They're in the wrong spot, and they're probably vertically incorrect as well. So Then we use one more technique to kind of close that gap. Okay, there's two things we can do. Two things we will do. Okay, can I go on to do that? Is there any questions about what I've done so far? Okay, so here's how you fix that. The problem is, if I go to the cross section, right, this thing is too short, right? From the edge of asphalt, I want to take this to the center line, right? And the center line is going to be, starts there, right? And then it moves. It gets further away. I'm going to move it. It gets further away. It gets further away and then comes back, right? And in the plan view, you can see that, right? It starts at the center line, and then it goes away from center and then comes back to center, right? I want to close that gap. So here's how you do it. You want to go to the cross section and tell this thing to get longer and shorter as required so that it matches the center line of the road. Okay, and there's a technique for that. Now, when you look at this assembly, I'm going to look at this, right click, and I go to my assembly properties. If I go to the construction, you'll see 1, 2, 3 links on one side, right, and you'll highlight them here. You'll see the boulevard, the top of curb, and the face of curb, and then on the right side, you'll see the gutter and the pavement. Right? This is the pavement line here, right? So there's 3 on this side, right? 1, 2, 3 pieces on the left, and 1, 2 pieces on the right, okay? But if you go to your properties and you click on one of them, the names are all the same. This is the confusing part. It's a link with slope, and this is a link with slope, and this is a link with slope, and this is a link with slope. It's hard to find the needle in a haystack. So this piece here, which I know has to get longer and shorter, I'm going to change the name. I'm going to call it pavement. Okay, so I'm going to change the name here, and I call it pave. It's the only one that's not the standard name, right? So when I go into the properties for this, if I go to construction, you'll see all the names are the same except that one. That's the one I want to change. I want to tell it to behave a little bit differently. Okay, so it's convenient to change the name of the one you know you want to find on the list. So in the corridor, I'm going to change my screen view. I'm going to split my screen. Don't do this. This is just for demonstration purposes. Okay, I'm going to split my view. So I'm going to go to view, and I'm going to go to views. Where is it? Sorry, I do it from here. View, and I'm going to go to viewports, and I'm going to go to 2 viewports, and I want to split it vertical. Okay. I'm actually going to split my model space into 2 parts. Okay, this is not paper space model space, this is all model space. Okay, so now I have 2 views of the same thing. Okay, don't do this. I'm just doing this so you can see what happens. In this case here now I'm going to show in 3D. So I'm going to go to Object Viewer, and I'm going to tilt this so that we can see what's happening here. I want to go down kind of the barrel here, if you can see, so that you can see the effects. Okay, so here's the center line of the road where there's no white line, and here's that edge that's in the wrong spot. I want this pavement to get longer. I want it to match the center position, and then I want it to match vertically as well, right? Because what's happening on the center line is correct. So I just want to show this to you. I'm going to fix this view, and that's what's going to show up in here. So now in 3D, you can see what's happening here. So I'm going to make the changes here. I want you to see them happening on this side. You don't need to do this. When you do everything I'm asking you to do on this side, this automatically happens. But for learning purposes, for teaching, it's convenient to see what's happening. Okay. So what we do in the corridor is this. Okay. So again, this view, this 3D view is not necessary. Okay. It's only here for the demonstration. So I'm going to click here. I'm going to right click, and I'm going to go to corridor properties. And I'm going to change this. So for this particular assembly, for this particular region, right? Notice it's blue when I highlight it, right? It's blue. For this one here, I'm going to go over to where it says targets, and I'm going to click this button here. Okay, and I'm going to do it off to the side so you can see everything happen as it happens. So I'm going to scroll over, and I'm going to click on the target for this last piece. And see how I can find the needle in a haystack? That's why I changed the name. Otherwise, they're all the same. So I'm going to do this twice, you could do it all at once, right? But I'm going to do it twice so you can see the effects. First thing I'm going to do is say, hey, that piece, I want you to stretch it so that the end of it is exactly where the main road center line is. Okay, and you'll be able to see that happen in both views. So I'm going to say, okay, for this piece called pave, and ignore this, the horizontal, which is this piece here, right, the offset, I want this piece pave to match the alignment called center line of road, the original road center line. Right? And you have to click this button here, add, and then that data shows up here. So this is the instruction to tell the that piece. It's only 3.5 meters wide. I'm saying stretch yourself, each piece, go to the center line of the road. Okay? Say okay. And when I say okay, watch what happens. Say okay. Okay. Watch what happens in the plan view. Watch what happens in the 3D view. Say okay. And I'm going to rebuild. And now they all stretch. They all get longer to touch the main road center line. Okay. But if you zoom in here, you'll see, it's hard, you can't see it in the plan view, but in this 3D view, you see the elevation. There's a gap here. Vertically, they're not the same. So horizontally, they have the same position. So in the plan view, it looks perfect. But in the vertical, it's wrong. They don't have the same elevation. So now you have to give it a vertical target. So I want to close that gap. These widened pieces just got longer, maintaining the 2% that I originally put in the cross section. So what I want to do is make these ones not only stretch to center horizontally, but now match the center line elevation vertically. So then we go back to the targeting. We go back to the targeting for this piece here. And I go to target for this piece. So I have the horizontal target. Now I go to the elevation. I go to the last one, and I say, okay, go to that road. Right? So go to the profile for Street X, the main road, right? And find the finished ground, the design profile of the road. Add that to your instruction. Say okay. Say okay. Watch what happens right here in this left side. The gap is going to be closed. That top white line is going to come down to match the bottom one. Watch. Rebuild. And now the elevations are the same. So what I've done is called targeting. It's going to horizontally go to the position of the center line and vertically match the design elevation at the center line. And now it gives you a final model of the pavement. Why is this pavement important? Well, when you put in maintenance holes, now it knows what the elevation of the top of the maintenance hole is. From the surface, remember there's a surface here. Let me bring back the surface. The surface roads. When I create my database, it'll get the elevation for the top of the maintenance hole from this surface. So and let's look at this in 3D, object viewer. All right, now you can see it looks like one continuous pavement, one continuous curb line. Okay, which is exactly what I think a lot of you already knew in your mind's eye, what it should be, but that's how you make it actually happen. You can see it's a nice, smooth, continuous transition all the way around. It looks exactly the way it's supposed to. And we'll do a similar exercise here. Right? This is wrong right now as well. Okay, let me get rid of this 3D view. Again, it's not necessary. You don't need to see that in 3D, but I think it's easier to understand what targeting does if you actually watch it happen. So let me get rid of my views. Viewports 1. Okay. All right, so you don't need to see it in 3D. Okay, so that's how you create your widening for the crescent. Let me turn this off. Okay, so now it looks like the true model of what that pavement or asphalt is supposed to look like. Okay. And we also have the design all the way to the edge of the right-of-way. Okay, not quite, but almost. Okay. There's one more housekeeping tip I'm going to give you before we get started before we finish for today. Any questions about that? So this targeting is how you get the widening pavement to behave according to the elevation we want. Okay, now there's one more piece of housekeeping. So everybody understand if you have maintenance holes here, that the elevation of the maintenance hole is going to come from the surface that the corridor built? Is there any question about that? That's what we're going to use it for. So this corridor surface is required to get the top of the maintenance hole elevation when you do your servicing design. The surface from the corridor has another function. When we do our lot grading design, I want to know the elevation at all the front lot corners. What's the elevation at all the front lot corners? And I can get those elevations from this corridor surface as well. So this corridor surface is required to do your grading. The corridor surface is required to do your servicing. For servicing, it gives you the top of the maintenance hole, the finished top elevation of the maintenance hole. For the design of the grading, it gives you the elevation at the front of the lot. Right? All these blue dots at the front of the lot. So if I create a point, I'm going to create a point, a Civil 3D point. Points, create points. I'm just going to create one. A manual point. I'm going to put it on the end of the line. It has an elevation 0, right? So the elevation is no good. There's a function, and we're going to make use of this. We're going to actually do this twice. There's an elevation at the front. I'm going to get elevations from surface, from the proposed road. Say OK, and it automatically populates what the front lot corner should be. I can create a point at the back. Points, create points. Manual, put one at the back of the lot. Elevation is 0. And I want to get an elevation at the back of the lot, elevation from surface, but not from the proposed road, but from the existing ground surface. Because I want to match the existing elevations at the back of the lot. So now I have an elevation at the front, born from the corridor surface of design, and I have an elevation at the back, born from the existing ground that we modeled in the first assignment. So you need the first assignment surface to be correct to get this elevation, and you need the third assignment corridor model surface to be correct to get the front lot corner. Right? So this elevation comes from the road surface, and this elevation, same function, comes from the existing ground surface. And now I have an elevation at the front, an elevation at the back. I'll teach you what to do in between after the break. So the assignment number 3 is to create the vertical alignment, to create the cross-section, the assembly, and create the corridor. Then you want to adjust the corridor. Make sure the widening is representative. Right? And I didn't do this one. You have to do the same thing I did here. You need a horizontal alignment all the way around the gutter. You need a horizontal alignment. You need a vertical alignment all the way around the gutter. And you need a cross-section to go all the way around the gutter. Okay? And I suggest you try and reuse this one. Make sure that your horizontal alignment goes around so that the boulevard's always on the same side as the elbow. Okay? I'll talk more about that tomorrow. Next week. Okay? So once the corridor model is ready, at the end of assignment 3, when you hand it in, you're going to show me all the front lot corners in your entire subdivision and all the rear lot corners from your entire subdivision. I want to see that you're ready to start lot grading, because that's the condition. If I want to design the lot grading, I need the front proposed, the rear existing on the entire site. Okay? And that's what is the last thing you need to do for assignment 3, is get ready for grading. Okay? But to get ready for grading, you need your profile, you need your assembly, you need the corridor and the corridor surface. The corridor surface needs to represent correctly, so the elbow and the crescent needs to be modeled correctly using the alignment, the profile, and the cross-section that goes around your gutter for both locations, the crescent and the cul-de-sac. And then you need to use that targeting technique. Right? So exactly what I did here is exactly what you need to do here, but the geometry is different. That's the only difference, right? The horizontal alignment is a different shape. Are there any ways to see if your elevations are correct? No, Stephen. So this is why when you do your work, you have to make sure that what you just did is correct, because you're going to use that to do the next thing. And then that needs to be correct so you can use that to do the next thing. So think about the order here, right? I need my horizontal alignment. It needs to be correct. I need my vertical alignment. It needs to be correct. I need my cross-section. It needs to be correct. If that's correct, then the corridor model is correct. Then the surface for the corridor is correct, which gives me all my front lot corners everywhere correct. If my existing ground surface is good, I can get this one. So I have faith that this and this is true and the right number, because everything I did up to that point when I told that information off the two surfaces is correct. Okay? But there is a bit of a domino effect. If the profile's wrong, your corridor is wrong, that front lot corner is wrong. If the topo surface is wrong in places, then you're going to get the wrong elevation at the back of the lot. Okay? So there is a bit of a hierarchy, right? What comes first, what comes next? What you do previously, if you use that to do the next step, it better be correct. And then once you create that information, if you're going to use that going forward, that needs to be correct and so on. So for instance, for assignment 4, if the number at the front or the number at the back is wrong, then anything you do in between is also going to be wrong to begin with, right? If this is wrong and this is wrong, then what you do in between is also going to be wrong even before you start. Okay, so you have to kind of check in and make sure. That's why I could ask you to do this. Then can you use the object viewer to verify the code is? Yeah, I always look at it in 3D, right? So I look at I look at the surface at the end of the day. So I bring the surface back to life. Right? When I look at the surface object viewer, I make sure that there's no funny business, right? You can see it's very smooth. You can't tell where the 20-meter right-of-way ends and the widening begins. There's no step, there's no jog. Everything is nice and smooth. There's no spikes on the surface. And on this surface here, as a matter of fact, all these triangles to the outside, right? They don't mean anything. You can use a boundary, but instead of creating the geometry, you can go to the corridor. You can go to the corridor properties. You can actually go to not surfaces. That's how you create the surface. Or if you go to boundaries and you right-click here, you can say use the corridor extents. This doesn't always work, but you can try it. And this will kind of shrink wrap it. Rebuild. And now you get just that. So it gets rid of all those triangles outside that don't make sense. So now if you look at the surface in 3D, it's just the right-of-way width. Okay? So that's what you're ultimately after. So the crescent needs to be done as described. The cul-de-sac, the procedure is exactly the same. You need a horizontal alignment. You need a vertical alignment. You need a set assembly. And maybe you can use the same assembly here. Remember this assembly? 0 is here. It goes around, increases in this direction. Well, if you start here, right? If 0 is here and it increases in this direction, I can use the same assembly to go around the outside if the boulevard's on the left all the time. If you start 0 here and go around this way, then you'll have to create the mirror of that last gutter subassembly. The intersection, leave it alone. We're not going to do anything with that. Okay? There's nothing to do there. There is, but it's not important for what we're going to use this surface for. Right? So just the elbow and the crescent is all you need to model. Okay? The last thing, and I'll demonstrate it here, if I create a point, and I put it here, end point, and the elevation is 0, right? If I click on there, and I say right-click, elevations from surface, and I want the corridor elevation, watch what happens. Nothing. See how it's still 0? Right? If I put a point here, end point, and I click on that, you can select more than one, elevation from surface, get it from the road surface, they're 0. They don't change. Why? If you zoom in, you'll see the surface ends here, this point is out of the range. So if there's no surface where the point is, it's not going to get an elevation. So here's the last tip, the last trick. When you create your assembly, remember this? The distance from the street line to the street line is exactly 20 meters. Well, that's the edge of the right-of-way. Never go to the edge, always go beyond. So what I'm going to do is I'm going to take this boulevard, and take this boulevard, and take this boulevard, and take this boulevard, all the boulevards. If I change them, they're all the same. They are all 555 at 2%. Well, instead of going right to the edge, I'm going to make it a little bit longer. So in this case here, instead of 5.55, I'm going to make it 6 wide. And when you widen the boulevards, you extended the lot a little bit, and this is what happens. So if you go back to your corridor now, your corridor is upset, right, because you made a change, right? So I'm going to right-click, I'm going to rebuild. Watch what happens. It's going to get fatter. It's going to expand into the lot. Whoops. Sorry, I'm just going to rebuild. Now it's wider. Now you can see the point is inside the limit of the surface, right? And that's true all the way around. This is the street line, but the edge of my surface is inside the lot a little bit. So now if I grab this point and all the points on the front lot corners, and I get an elevation from surface, roads is the design surface, I get an elevation. This is another example of never design to the edge of something. Always go a little bit wider. Give a little bit of extra kind of width to stuff, right? So just by extending that 2% plane of the boulevard a little bit wider beyond the actual street line into the lot a little bit, you can then cover the area where you want to get elevations from. So that's the trick. So to begin with, if you make it exactly 5.55, right now it's going to be wider, right? The distance from here to here is actually 0.9, right? An extra 45 centimeters on either side. There's no harm in that, right? Because to the street line it's correct, and to go a little bit beyond, a little bit fatter, just so you cover those areas. And the problem is always on the outside curve. Every time you're going around the curve on the outside, if you draw an arc, right? If you draw a circle, if you want to approximate that with straight lines, you want to approximate that with straight lines, nearest, where's my nearest? If I want to draw a polyline to approximate that, right, that looks like a curve, right? That looks like a curve at a glance, but if you zoom in, the circle is always beyond the edge of the straight line, so anything out here would be off the limit of the surface. So it's always on the outside turn that you have a problem. So just make the boulevard wider so that you don't stop at the street line, you go a little bit beyond. Okay. How far beyond doesn't matter, right? But it can't be at the street line, it's got to be a little bit further in. So I made it 6 meters, you could make it 6.5, you could make it 7, you could make it 10, it doesn't matter. You're not going to go that far, right? I can make these boulevards, all the boulevards, right? I can make them all 10 meters, right? If I make them 10 meters, when I rebuild the corridor, it gets a little bit fatter. But that doesn't change what the elevation would have been here. As long as it's passed, you're going to get a number, and that's what you're interested in. Okay, so it doesn't have to be that wide, but wider than the actual. Never stop at the edge, go a little bit further. Okay, so the description in the PDF on how to do this is a little bit different. I would follow exactly what I did. I like to model the gutter, but I did give an alternative here. Instead of modeling the gutter line as an alignment, in the PDF I actually show it creating an alignment on the edge of pavement, the edge of asphalt, right? This document here. So if you look here, I actually created the alignment, right? Not at the gutter line, but at the edge of asphalt. Right? The graphic's hard to tell. So then you have a profile of the edge of asphalt. The reason that is sometimes preferred is because the alignment then isn't exactly where your gutter is. So then you have your alignment in one position and the polyline that represents your gutter in another position. So then you can easily select one over the other. What I did is it's exactly the same spot. So when you look at mine, right, my horizontal alignment, let me get rid of the surface, is exactly on top of the gutter, right? So I drew my gutter. Let me get rid of this. Freeze my corridor, right? My gutter alignment is exactly on top of my gutter line. If you create an alignment 0.3 meters away, right? If you do this instead, if you put your alignment here, then it's in a separate location as opposed to the gutter line, okay? So that's the advantage of it's in different spots, so then you can easily select one and not the other. That's the reason for it, right? The problem with that is when you do the profile of the edge of asphalt, you're not going to get the gutter grade, you're going to get the edge of asphalt grade. It'll be very close to 1%. It'll be a little bit either flatter or steeper, but it'll always be at least 1%. Okay? This I like because it is the gutter. So this profile of the gutter is exactly what I need to compare to 1%. 0.3 meters away is almost 1%, plus or minus, but it'll always be a little bit steeper. So I like to model directly what it is I want to check, as opposed to model 0.3 meters away and, it's close, but is it exact? So there's two ways of doing it. I prefer what I demonstrated in class today versus what's actually shown in the PDF. Okay? But the PDF has all the steps, what to do first, what to do next. If you decide to model the edge of asphalt instead of your gutter line, the procedure is the same. The only difference is in this particular one, when you go to your assembly, remember it's edge of asphalt, the mistake I made would have been correct. Remember when I drew my sub-assembly? if you go to your sub-assembly, right, if you look here, the actual, the point is actually on the edge of asphalt, not the gutter, right? So you have to be consistent. If you draw your alignment at the asphalt edge, then the assembly point represents the asphalt. If you draw your horizontal alignment at the gutter, then the assembly point represents the gutter, and then you have to proceed accordingly. Okay? So be careful about that. It doesn't matter how you do it. It really doesn't matter whether you do what I did in class or whether you follow this procedure here as a guide. You're going to get the same model, but you have to be consistent. Once you commit to the gutter, if this is your gutter, then your assembly has to be in the gutter. If the alignment represents the edge of asphalt, then your assembly is here at the edge of asphalt. Okay, so you just need to be consistent with that, that's all. It's not wrong, it's just different. For ease of marking, did you want us to do... I don't care. What I check doesn't, when I check it, it doesn't matter. Okay, so whatever you decide. I would prefer you do exactly what I did during the demonstration today. Model the gutter line. That's my preferred method. But if you go the other way, as long as you're consistent, there's nothing wrong with that. Any other questions? Okay, so it's a really simple technique. It looks complicated to create, right? But when you look at the final result, sorry, let me share my screen again. When you look at the model, go back to the model. When you actually look at the model, it's actually very, very simple. Like, it's very neat and tidy, and it looks exactly the way you expect it to look. If there's an error, and that's why you should always look at these things in 3D. If there's a step, here's a common error. Say you did this wrong. If you didn't put the elevation at the right spot, say you put it down here, for some reason you didn't snap properly, watch what happens to the model. At the beginning, there's going to be a problem here now. Watch, you're going to rebuild this. I'm going to grab this, look at it in 3D. Oh, it's a little bit, there's a bit of a step there. See that? You can actually see the step. It looks like garbage, right? And this thing here looks a little bit funny. So something's gone kind of wacky. Right? So when you look at it in 3D, you can see that, there's a problem. It looks like, my profile of my gutter is too low. It doesn't match this part of the road. So then if you check your projections and stuff, say, oh yeah, see, I forgot to snap here. This should be exactly here. And then if I rebuild the surface, I look at this in 3D again. Yeah, right, that outside edge looks pretty good now. Everything looks nice and smooth. I don't see a step there anymore, so the outside gets modeled properly. Okay, this is okay on the inside, right? It's just a transition. Don't worry about this. Okay, it's the outside that's important right here. Right? This is going to be. This looks kind of. It's like a spiral staircase, right? You're going uphill this way over a long distance. Now you're going up over a short distance, right? Where they're all coming together. So it's actually modeling it correctly. It's actually doing the right thing. Right? And what we're going to do here is, I need an elevation at this point and at this point. So this issue here is not a big problem. Right? This is that 10 meter wide thing. Let me go back to 6, it won't look so bad. So let me change this profile, these boulevards to 6 instead of 10. Right? A little bit wide, doesn't have to be terribly wide, right? So now it's going to shrink a little bit, it's still wider. Rebuild. Now it's not so bad. Now you can see the transition's nice and smooth. Object viewer, nice and clean. So that's a common mistake. Sometimes you'll see that step on the outside because the profile doesn't match the typical 20. Okay? And then if I want to create a point, create points, manual, I'm going to put one here, and these two elevations are now inside the surface. Elevation from surface, my design elevation comes from that road. I get numbers. And now that's my lot grading and so on, right? So all the front lot corners. So the last thing I want to do, I will share this for the assignment. So assignments. Assignments. There is a number 3. I'll make it available right now. Everybody always asks, edit. Make the assignment available. So now assignment 3 is available. I should be able to see it. And what it looks like, I'll just explain to you so you know what you're finally after. Assignment number 3. Sorry here. Oops. Assignment number 3. So it explains why you're doing this. And then it also explains how to create the front lot corners, how to create the back lots. Right? So every front lot corner, all those values you see in red, they're all 0. But then you right click, you put them all on one layer, you right click, select similar, it selects them all, and then you right click and choose the corridor surface. And then you do the same on the outside. Right? It gives you a style you need to create, no big deal. Right? Then you put points along the perimeter of the site at the back of all the lots. And then you select one, you select similar, and then it describes getting the elevation from the surface and so on. Okay? There's one more thing to teach. I'm not going to do that now. Right? How to get the front lot corners on the existing road instead of the proposed road. I'll teach you that next week. There's only like 5 or 6 points to take care of, so we'll do that last. Okay? I don't want to overwhelm you with too much today. So that's the last piece. So when you're done, your drawing should look like, when you're done, let me go to the last page. Your final drawing should look like this throughout. An elevation at the front from the corridor surface, an elevation at the back from the existing surface throughout the entire subdivision. Right, so I don't know if there's a full shot here. And this describes exactly how to do it. Right? So this is basically what your drawing will look like when you're done. 2 different layers for existing at the back, proposed at the front. 2 different groups, 2 different styles for each group. So now we're starting to make some previous skills with the new stuff and so on. Okay? But you can't do any of this until you have 2 surfaces. Existing, which you should already have, and then the proposed corridor model, which won't represent until you do the cul-de-sac and the crescent. Okay? So don't get too far ahead of yourself. Do one thing at a time, and eventually you'll get to the end. Okay? So this is ready to go. Now my front lot corner here, right? My front lot corner here, right here, and here. Right? I want the elevation for these all the way around the cul-de-sac. Elevation from surface. Proposed. Why? Because the model's wrong. It doesn't extend around the bulb like we did it here. Okay, so you have to create that model. Okay, and when you're done, you'll have points all along the front throughout the entire subdivision and all along the back through the entire subdivision. Front comes from this corridor surface, back comes from the existing ground surface. Okay, sounds like a lot of work, but it's not. The hard part is the corridor model. Once you have 2 surfaces, then it's just a matter of process. Put points in everywhere, make sure they're on the right layer, make sure they're in the right group, create styles for each group, and then you can do more than one, right? I can click on this, right? I can click on 1, select similar, it'll pick all the points on that layer, right? It'll pick all the points on the front, that's one layer, this is wrong, this will be on a different layer, right? So you select all the front lot points, right click, select similar, and then elevation from surface, from the roads, boom, you get all the front lot corners for free on the entire site. That's what we're ultimately after. Right? Instead of calculating each one, imagine you had to calculate, what station value is this? So you go to the station value from the horizontal alignment, there's a station. Then you go to the vertical alignment to calculate the elevation of the center line, and then you go to the cross section to transfer the elevation from the center all the way to the straight line. Imagine doing that for every lot corner. This surface allows you to get all your front lot corners at once for the entire subdivision. That's the advantage of using a corridor. Same thing with the top of the maintenance holes, right? Once you create those, once you create the pipe database, you can ask all the maintenance holes to get their elevations from the surface, right? So if the corridor and the surface for the corridor is correct, you get a lot of free stuff. So you're doing something very sophisticated in order to simplify some of the more mundane things. Okay, so it looks like a lot of work, but it saves a lot of other work. Okay? It looks like a difficult thing to do, but it makes something that's very, very boring and repetitive happen very quickly. Right? Front block corners and top maintenance elevations. Okay, I think I've said enough for today. You can do everything except the elevations at the front block corners, right? These elevations, right? These for the existing road. It explains it in the assignment, so if you want to try it on your own, you can, but I will do a demonstration of it next week. Right? So then you have to put in 1, 2, 3, 4, 5, 6 more points using a varied technique, which I'll show you next week. Okay? But certainly you can do the bulk of it. You can do most of the subdivision. Okay? So at the very least, you want to have your corridor model ready to go, and then create the points at the front and at the back. That doesn't take long. Okay? And then this last piece, proposed elevations at the front of the existing road. That's described, but I will cover it next week. Okay, so that's as much as I want to do today. You should have all got your assignment results. I did make a mistake on the marking, not your marks, but the actual what each thing was out of. So I had to update that. So I sent everybody another update, another email with an update. And again, if you're not sure, if you didn't get 4 out of 4 on those 2 items, and you're not sure how to fix it, take a look at what I described, and if you still can't figure it out, send me an email, and if I can describe it to you in an email quickly, I will. Otherwise, I'll ask you to join me in a private meeting where we can do a video chat, and I can demonstrate where you might have went wrong. Okay, so that's it for today. I'm going to stop recording.